So hello everybody, my name is Albuquerque and I just finished a degree as well, like a month ago, here in the Faculty of Engineering. And I'm starting a position as a backend developer in the Netherlands at Sept agency. So there's my contacts if you have any questions by the end or if you just want to contact me. I'm going to talk a bit about my thesis, so it's all about cloud monitoring patterns. And as you see, recent trends in cloud and microservices adoption have been kind of changing the way we organize and architect our applications, right? So things are getting more complex, a bit more distributed, and monitoring needs to change so we can actually still be able to monitor things properly. And that's what the industry did, okay? So they adapted and new monitoring practices emerged, and most of those practices, as you may see, really depend on the context of the company and what they pretend to achieve. And they can most of the times also be reflected in tools. So if their company adopts X tool or Y tool and they do whatever they want to. The problem with these practices is that they're not always evident. So here's the deal. If company X just around the corner uses certain practice, that doesn't mean that we can just automatically use it, even if we know that they're doing it. They are difficult to learn and hard to communicate, mostly because there's no standard format or definite level of detail that all of the practices share. It's really hard to understand what's something when you can really just transfer knowledge from place to place. And even worse, we didn't really find a lot of research regarding the topic, so we went forward and we decided to formalize these practices as design patterns. Okay, Paul already explained design patterns to you, so I'll skip this part. What we did was basically study whatever existed, so monitoring practices and design patterns that already existed out there in the literature. And then we developed our new design patterns. We also just picked some and enhanced them and kind of refined them a little bit to give some more detail. And then we went on to evaluating these new patterns that we proposed in our thesis with a company here from Porto called Consulting. That we developed a thesis with them and we ran a case study with a project there. And to finally the big objective of this whole research was to get a catalog of patterns for monitoring cloud applications. And the cool thing about this catalog is that it's really useful for practitioners and the industry overall. Most of you may already use or have used design patterns, and you know that it's really cool to pick a pattern and try to apply it on a context that really wants it, that really needs it. And that said, we went on with a literature review. I'm not showing everything here, of course, but that's some of the most interesting works, especially the books. I think you guys will really enjoy these books. The first one, Building Microservices, from Sam Newman, got the second edition 1 year ago. It's very up to date. It's very cool, very practical, very easygoing. So it's a really cool book that I recommend everyone to read. And on more on the academic side, we also have this PhD thesis from Professor Tiago Souza, entitled Engineering Software for the Cloud, a Pattern Language. So it proposes a bunch of patterns towards everyone that's developing or just maintaining something on the cloud. They're very detailed, they're very meticulous, and it's really interesting, and they are very good patterns to apply in practice as well. So after everything, we ended up with 11 design patterns, okay? And that's them here. Let's just dive into it. So we started with the logging patterns on the left. So we have audit logging. Basically, it suggests that you should use logs to record user activity, either for auditing processes or just helping and supporting customer service that can really understand what the user did. These logs are immutable, and so you can save them securely, and they actually have legal value. Another pattern called standard logging. It's kind of straightforward. Essentially, as many teams work on different parts of your application or in different services, it's good and you should have a standard format for all your logs so they can be easily exchanged and even consumed by third-party applications. Log sampling, it's kind of straightforward as well. So, logs start to pile up as the application grows, and at some point, it's really a pain in the ass to manage. So, you sample logs in some intelligent way to maximize the information you get while minimizing the amount of logs you need to store. All these patterns here, they kind of support distributed tracing in the sense that commonly tracing is based on information that's passed through logs. So I'll just explain the pattern here. Distributed tracing consists of understanding the way a user request flows through your application, okay? Most of the times that happens through logs, they get a correlation ID, and that thing gets passed on, and you can then understand where the request has been, how long it has spent on each part of your application, and even some events or some extra information that you want to stuff into it. It's really important. It's a very common practice that's emerging, and there are very many tools around it. You can also extend this kind of tracing with some tracking of relevant events. For once, you have exception tracking. So exceptions are critical error. Right? If anything goes wrong and there's an exception, we want to tackle it right away. So it's important that you have a specialized system to tackle exceptions that handles the application, that ensures the stack trace is fully saved, and you can actually get on with it and troubleshoot your application from there. When it comes to deployment tracking, as deployments are major changes in your system, it's most likely that an error has been caused by a deployment. It's always cool that if you can understand where exactly in time did you make some sort of mistake, there's you still find out. So if you track your deployments, you can then correlate other metrics of the system, and we'll get there, with the deployments themselves and find the source of the problem. So in this column here, I already talked about these two, but all these patterns, they feed into metrics, okay? They're basically event generators. You can generate information out of things that are happening. And so let me just explain really quick these two up here, liveness health endpoint and readiness health endpoint. They're very similar. Our service or application, they will expose an endpoint that, for once, either in the case of the liveness health endpoint, shows the liveness status of your service, so if it's crashed or not, essentially. And if it is, you can automatically restart it and everything will go smoothly, hopefully. And when it comes to the readiness health endpoint, it's more about, is it really ready to reply to user requests? So it may be up, but it might still need some background processing or some dependencies, so you kind of still need to wait for it a little longer before routing traffic to that service. When it comes to synthetic testing, it's quite simple. You grab a bunch of your tests, or all of them if you can, and from pre-production stages, and you get them running periodically in your production system. Because at the end of the day, that's what users are using. You want to keep your system. You want to be sure that it's still behaving as expected. Finally, last two patterns, application metrics and infrastructure metrics. It's kind of straightforward. We collect, we manage, and we store metrics so we can actually take more informed decisions on our system. And it comes in two levels. So either application, which is mostly high-level stuff, right? Like the number of logins, number of visualizations of a video, or even like throughputs of user requests per minute. And we can also, and we should also, store infrastructure metrics, which is mostly related to the machine itself. So CPU usage, memory usage. They're not necessarily the problem, but they are good symptoms that something might be wrong. And yeah, that's it for the patterns. I didn't dive into too much detail, but patterns are really helpful for practice, okay? They're practice oriented. So I think that if you read the patterns, you pretty much learn something. They go into much detail regarding trade-offs and things that you should consider when you're adopting something. And they're not that hard to adopt because most of them point to tools, okay? These are just some that we used and that are mentioned in our patterns. So yeah. Because the thesis was developed with a company, it's actually under embargo yet. So we're actually looking into a way to make this whole pattern catalog available. As soon as we get it, possibly in a Notion file, we will